13. Okay, I then come over here and I plot those points. So at negative 2, I'm up here at 12 off the graph. At negative 1, I'm down to 1. At 0, I'm down to 1, 2, 3, 4. At 1, I'm down to negative 3. At 2, I'm down to 4. And at 3, I'm off the graph. Okay, I would connect the dots. Okay, so I have now graphed it. And if we keep reading the directions there, it says, and if I'd look at my graph one more time, okay, it looks kind of close. Okay, then it says, determine the consecutive values where x is between, or of x, which each 0 is located. Alright, again, the 0 of the function, how many zeros are on this one? There's only 1, and it doesn't actually cross even, but where do I always find the zeros of my function? Those are always located where? Where my signs change. So therefore, on this problem, where is the 0 function going to be in between? So for part B, this will be part A. Part B, where are the zeros of the function? They're between negative 2 and negative 1. Okay, and then part C. Estimate the x-coordinates at which the relative maxima and the minimum occur. Well, I know there's two spots here. This would be a maximum, and this would probably be a minimum. So where is my maximum for part C? And my maximum height there would be, we're looking for the x value, so estimate the x coordinates, not the y coordinates. So what x coordinate would that match up to here? By the looks of it, the max would be where x equals 1. Okay, that's one answer. And where is the minimum going to be at? If we look at the minimum, back to the x coordinate here would be equal to 0, so that's where my minimum would end up. Let's go back to full screen here. Okay, so state the degree and the leading coefficient of each polynomial. So if I look up here, my degree would be the highest power. So if I look up here, this is the power of 1. What's the highest power? This guy here. Okay, so therefore, my degree on this problem would be 2. That's this guy up here. And my leading coefficient is the number in front of that degree, and that would have to be a negative 1. So therefore, negative 1 would be my leading coefficient. Okay, state the degree and the leading coefficient of the polynomial. So I look up here now, I look at all my degrees. I got a 3, I got a 2, I got a 5, and I got a nothing. 5 is the biggest number. It's degree 5. Leading coefficient is the number that's with that degree. So 8 would be my leading coefficient. Alright, if h of x equals 3x squared minus 1 and r of x equals 2 minus 3x, find r of x plus 2. Okay, so if you review from yesterday, from the other days, if I had r of 2, what am I going to do with that 2? I'm going to take that and I'm going to plug it into the r function here. Okay, I don't have r of 2 though. I have r of x plus 2. So what am I going to plug in to my function? I'm going to plug into my function at x plus 2. So I'm going to rewrite my function as 2 minus 3, but where my x used to be, what is now replacing that? And that would be this part right here. So it would be an x plus 2. Is replacing this x right here. Okay, so now let's simplify this problem here. What do I do with this negative 3? It's in front of the parentheses, you must distribute that. So I'd leave the 2 up in front, not doing anything with that. Get a negative 3x and get a negative 6. And last step here, combine like terms. 2 minus 6 gives me a negative 4. and there is my solution. Got 3 more problems left here. Alright, so same problem, except now this time it says find 2h of a to the 4th. Well, am I going to be using this Rx formula here? I'm not, so I actually don't even need to use that, so I can erase that. But what I am doing here is I'm having a 2 here. What's happening with this 2 and the h? They're being multiplied. So again, all this h here tells me is that it's the h function. So I actually don't even use this h. So if I'm going to write this out, it's going to be 2 times h of x, or the h function, so whatever h of x is here. Okay, so if you look up here, h of x is this function right here. But I'm not going to just write that function into my parentheses. I actually have to plug something in right here. So what am I going to do with this a to the 4th? I'm going to plug that in. So it's going to be 3, parenthesis, plug in my a to the 4th, and then you just keep writing that problem out. Alright, so now I plugged it in, and then I just simplify just using PEMDAS. So power to power, what's the rule? We multiply, so I get 3, a to the 4 times 2, that is 8. When you multiply this power to power, it's a to the 4th squared, so it'd be like a to the 4th times a to the 4th, which is a times a times a times a times. So 4 and 4, that gives me 8 of them. Okay? And then minus 1. And then what's still out in the front of this parenthesis? The times by 2. So what do we have to do with that? Distribute, and I get 6 a to the 8th minus 2. Alright. For each graph, describe the end behavior. B, determine whether it represents an odd degree or even degree function. And C, state the number of real zeros. Well, part A, what is the end behavior? End behaviors are this guy and this guy because they're at the end. So, as x goes, you have to do 2 of these. So some of you guys, when you did your worksheet the other day, only did 1. You have to say both the left and the right side. So x goes to infinity, and x has to go to negative infinity. Okay, and if you just want to say what direction it goes, you can do that. So this one's up. So as x goes to infinity, you guys can follow along, you can see that goes in the upward direction. And as x goes to negative infinity, if you follow along here, that also goes in the upward direction, so therefore they both go up. Part B, determine whether it represents an odd or even degree, how many times, even degrees go in the same direction, odds are different, and since they go on the same here, they're both up, therefore that has to be even. And C, say the number of real zeros. How many times is this crossed if we look here? Oops. How many times does that cross? And if you look there, it crosses 3. Once, one bounce here, and there. So this one will actually cross 3 times. If I lifted it up a little higher, it would have crossed 4, but the way I drew it, it only crossed 3 times, and that's okay. Alright, and the last problem. For each graph, describe the end behavior. So again, end behaviors, you need both parts. When x goes to infinity, and when x goes to negative infinity. So when x goes to infinity, that means it goes to the right. So as x goes to this direction, what happens to my graph? It keeps going what? Up. Alright? If x goes into the left, to negative infinity, which way does my graph go? Down. Okay, part B. Determine whether it represents an odd or even degree. If they're going in opposite directions, we didn't know that is odd. And C, how many zeros of the function do we have here? 1, 2, and 3. And And that right there is everything that is going to be on our Chapter 5 test. So for those of you guys that didn't do well in the last one, this will be a test I think that will really help you to benefit your grade and kind of help it get a little higher. So if you have any questions, come find me. And test is going to be tomorrow. So thank you. Have a good day.